Okay, so here I'm going to talk about logarithmic functions. So we're kind of introducing what they are, how their graph looks like, and what are their properties. So we're going to talk about those things here. So first, let's start with this. So remember, when you have an exponential function like this, let's say 2 to the x, we know what the graph looks like. But let me just quickly remind you, because it's really going to be the key here. So let's say I plug some numbers here. Let's say -2, and this will be 2 to the -2, which will be 1/4. Okay, and if I do -1, so this is 2 to the -1, which is a half. If I plug 0, so this is 2 to the 0, 1. If I plug 1, it's going to be 2. If I plug 2, it's going to be 2 squared equals 4. So these are some points that I get. So now let me just try to plot this. I mean, you already know what the graph looks like, but like I said, this is going to give us something in a little bit. So let's say 1, 2, 1, 2, 1, 2, 3, 4. Okay, so this point, -2, 1/4 is going to be maybe somewhere here, and the -1, -1/2 is going to be right here, and 0, 1 is here, 1, 1, 2 is here, and 2, 4 is here. So that's our exponential function, right? So we have that. You know, this is just going to keep going. Of course, it's going to push to 0 like this. Okay. So now, what is the inverse graph of this looks like, right? That's what I'm after. I want to know what is the inverse of this graph. Well, remember, with the inverse, we were just switching the point, right? I can find the points by switching them. So I'm going to basically switch x and y in this table here. So therefore, I'll get 1. So if I switch it, now my new values are going to be this, right? I have 1/4 here and -2, 1/2, -1, 1, 0, 2, 1, 4, 2, right? And then if I plot this point now, then I'm going to get something like this, right? So 1/4, so this is 1, 2, 1/4 -2 is going to be like a point maybe right here. And then 1/2 -1 is probably going to be like a point right here. And 1, 0 is right here. 2, 1 is right here. And then you'll have 4, so 3, 4, 4, 2 is right here. So you see, we're getting a graph like this. This is y equal 2 to the x. And now I have the inverse graph of that. I don't know what is the equation yet. So equation, I don't know, right? But I do know the graph of inverse of this. So basically, if I just know the inverse of this, then I have the graph already. So I'm just going to figure out what is the equation of this graph. And they're logarithmic functions. I mean, you probably guess it by now. So now I'm gonna define what these are. Okay. All right. So now we start with an exponential function, and we try to find an inverse of that, right? That's what this is about. So, okay, so then I will do this. So we have an exponential function, right? And to find the inverse of this, remember we were switching x and y, so this will turn into x, and this will be y. And now the inverse of, and I'm gonna have to solve this for y. So when I solve for y, then I will get this function. So log is short for logarithm, and this is the base of exponential, and it's also a base of logarithm, so we call this number base. And then this is the input. X values are the input, so I will put it as an input here, and then equal to y. So basically, this is very crucial. I'm going to write this, so I'm going to say input equal base output. So whenever we have an exponential function, we always have this form, and this form can be converted to this form, and I'll write it like this: log, and we put the base number here, we put the input here, and the output is here. So I can go I can go back and forth. So I can go from exponential to this form and from log form to exponential form because they're inverse of each other. And this way is very convenient because we can always use this conversion back and forth to solve any exponential equation or to solve any logarithmic equation. So it's very, very convenient. So I suggest that you write this somewhere, and when you're working problems, always take a look at this before you start it. Okay, so let me just give you an example how to do this conversion. So basically, log and exponential are inverse of each other now, right? So we established that now. Okay, so let's take this thing. So let's say I have 2 to the x equals 5, and that's an exponential equation, and I want to convert this to a log equation. Well, let's identify what I have right now. So I have 2, which is base. Okay. And then I have this guy, which is an input, right? Because when we have an exponential form, remember I said here, you have input equal base to the output. And this number right here is going to be the output. So when I convert this to log, okay, so first I'm going to put my log here. Log is a function here, right? And this function will always take an input. So my input is 5 here. Okay, and the base is 2 here. And then that equals x. We solve for x. As you see, normally this will be a hard problem to solve, right? Without a calculator. But now we solve it. Okay, now what is the value of, so what does that mean? Well, this is just going to be a number, right? So to do this in a calculator, there are some logarithms that we can do by hand, but on some we have to use a calculator. So to do this in a calculator and find the value of x, we'll just do, I mean, you can just enter it as it is. You know, if you're able to put the base in your calculator for logarithm, then you can just put it as it is. If not, then you can just do this. So do the log of input. This is called a change of base. So log of input, and then the log of the base. Okay, and here, if I don't specify a base, the base is always 10, and that's the default. It's already set in your calculator. You don't have to put anything. Just write it like this, and then you'll have a value for x. Okay. I mean, you can put any base you want, like I said here in this form. So I can put, like, let's say 3 here. Okay, but the reason I didn't put anything, I choose the natural base because I want to plug it in a calculator without entering any other base other than 10. Okay, so you can just put this in calculator and you have the value of x. Now let me show you another example that you have to convert from log to exponential. So let's say we have this. I want to start something like this. Let's say log base 5, and over here I have, let's say, x plus 3, and this equals, let's say, 2. Okay, I want to convert this and then solve it for x maybe. So how do I convert? Well, at first, let me just see what I have, right? So this number here is base. Okay. And this right here could be an expression or a number. So this is the input. And this number right here is the output, right? So when I convert it, remember, when I convert it to an exponential will always have this form. It will always be input equal to base to output. So what is input here? So then I'm just placing my numbers here in this form. The input is x plus 3, the base is 5, and the output is 2. Okay, and then I just compute this. So x plus 3 equals 5 to the second power is 25. Then subtract 3 from both sides, so x equals 22. Value of x. You see, it's easier to solve equation when you convert them to each other. So it's a very useful identity. Okay, so that's this, and I want to now talk about some properties now because we know this conversion, so we can easily publish properties as well. So properties of logarithm. Okay, so the first property is, okay, so if you have a log with the base a, and then you have, let's say, 1 here. Now, you know, imagine this is like equal to, let's say, x, right? And how you will convert this? You will convert this to an exponential like this, right? Input, which is 1, equal to base to the output. So a to power x equals 1. So a to what power is 1? 0 power, right? A to 0 power is 1. So therefore x equals 0. So this means log with the base a, input 1 will always be 0. So as long as input is 1, then it's always 0. So you see, I can just convert it to log to find the answer. And then similarly, you can do this. If the base and the input of log are the same number, then you will always get 1. Okay, so as an example, log base 7 and input is also 7, so this will always be 1. Okay. That's that. Now, property 3, I have a log. Okay, log base a, and then I have a b here. Okay, these two are not the same now, right? Because property 3, if they're the same, you get 1. If they're not the same, then what happened? Well, then I will write b. Write b as an exponent. Write b as an exponent. Base a. Base a, if possible. It may not be possible, but if I'm doing things by hand, then it should be possible. So with base a. Okay, so that means basically we should be able to write it as a to the some power, right? Maybe power, let's say x. So then this will be log a to the x. And when this is the case, then the answer will just be x. Okay, because these two are now matching. If these two match, then the answer will just be x. Okay, so as an example, let's say log 2 8. Now I'm taking 8 and writing it as an exponent, which will be 2 times 4, 2 times 2. So 8 is 2 to the 3. So I was able to write it with the base 2. So therefore, this will be log 2 to the 3, and that will give you 3. So I will continue more properties and more example in the next video.